under the current scenario. And these will lead to new kinds of jobs, new kind of opportunities, especially in this area of connected solutions. So with that, I wanted to expand the horizons. I wanted to bring about an introduction to IoT and the kind of applications that we are seeing now. And hopefully it is something that you can look as a career option as well. Right. Now, IoT, it's very difficult to kind of define IoT. So what I'll do is I'll try to take you guys through IoT in terms of its characteristics. Right. The first thing is that IoT is kind of near invisible. It is not in our face. It kind of stays in the background. To illustrate this point, let me just take you through this video.
Every morning at 4:30, you hear the cooks talk on the floor. It's hard times in the mill, my love, hard times in the mill. Every morning just at 5, gotta get up, dead or alive. It's hard times in the mill, my love, hard times in the mill. Every morning right at 6, don't that old bell make you sick? Hard times in the mill, my love, hard times in the mill.
I know that the ad could have had some lag for many of you, but the point here is, as parents, even as we take care of our children, and do our utmost to ensure their safety, there are moments of lapses like this where we lose our concentration. And that is where you need a system that looks after us. In this case, the mechanics of the car, the intelligence of the car takes over and helps the lady stay on her track and avoid a catastrophic accident. And that's what IoT is about. It's about that protective system that can tell you that there is a potential failure point that is looming and can help you predict and even avoid that. IoT systems are connected at scale. In order to do this kind of a system, you need to have a large number of computing infrastructure all around you. But that didn't happen in one day. Right? So let's dig into the timeline to see how this scale kind of came about. If you look at the late 80s, before that you had mainframe computers and people would line up, they would have a timesheet and they would share the mainframe. But by the late 1980s, personal computers had come into the market. So there was one person who used to use one computer. They would go home, open up their computer, right, and they could use it. So the profile of the person was kind of captured within that one computing device. By the mid-90s, laptops were ubiquitous. So people had access to their data, especially sales guys who are on the move. They had access to business data even when they were not connected, right? They could carry their data with them. So that was the first instance when computing and data started moving around with the people. By the 2000s, feature phones and wireless communication had become pretty ubiquitous. Cell phones were there, and over generations, by the time it came to 2.5G or edge networks, it was possible to send some forms of data, MMS, and some amounts of IP traffic on the phone itself. But by 2005, social media had come into the picture, which meant that people had multiple devices. They were logging into their social media sites from multiple locations, and they were connecting to the internet because they wanted to know what was going on all around them, which kind of made them almost move away from the fixed internet connectivity towards something where their phones started to become always connected. Right? By 2010, the smartphones had come about, and Apple had launched its set of iPhones. So the whole mobile phone, the whole screen of the mobile phone has now become, was now being used for internet access. Rather than you getting a link for downloading an MMS, it now became where you could use the whole screen to browse an e-commerce site. Right? So the whole screen estate became more and more precious, and people started using their mobile phones more than their laptops or desktops. Right? So, and people started having multiple phones, right? So their profile was getting shared across multiple computing devices. In a couple of years, there was very high competition for the real estate that was there on the screen. Multiple apps were coming up and trying to claim that spot. Garage startups which nobody had heard about were becoming multi-billion dollar organizations. The Ubers of the world, the Airbnbs of the world, the, all these companies, they could, they were starting out from garages, and they were challenging the dominance of large corporate houses which had taken years and years to kind of build up their reputation. And how were they getting to the customer? Because they were delivering a service right through their mobile phone. To deliver these services, there was a wide set of infrastructure that was getting deployed, right? For example, if you wanted to use Uber, yes, you could press a button and you could book a car, but you knew every car was getting fitted with a GPS device, which meant that you had the location information of each and every one of those fleet at your fingertips. This started growing exponentially as well, right? Where uh, cashless society, smart cities started to come into the picture. And by smart cities, it meant that there was already a large deployment of infrastructure all over the city, and they were providing data. They were providing data which could be monetized. They were providing data which could be used by the citizens, right? For example, you could pass through toll booths without having to stop. Right? You can get the location of a public bus before you get to the bus stop. You know when your garbage is going to get picked up. You know when somebody is going to be there to deliver a package at your doorstep. So there are these connected systems that were being built up. So in essence, what was happening is these cashless systems, these IoT systems, not only was there an increase in the number of transactions that were happening over these IoT systems, there were more and more people who were using it. So it was an exponential increase in the number of IoT transactions per se. And this exponential increase in digital transactions was primarily due to more and more people using it, and each people using it more and more. So increased penetration of usage and increased depth of usage. To accelerate this fact, India started developing its own India technology stack, right? Today, you have something like an Aadhaar card, which is a digital identity. Today, you have something like a UPI, which is a digital cashless payment system. Today, you have something like a GST, right, which is a digital taxation system. There's also talk about blockchain, of India having its own blockchain policies, right? India having its own security mechanisms. So all these components are essentially enriching the mechanisms so that we can build apps which are going to be beneficial for all around us. It's saving time for all of us. Now, since we're talking about smart cities, I wanted to take you through another small video which is pretty self-explanatory.
Everyone wants their city to be safe, digitally savvy, and technologically accessible. That's why it's critical for cities to invest in infrastructure that makes smart living possible and sustainable. A smart city leverages digital technology to connect, protect, and enhance the lives of residents. The Internet of Things, or IoT, acts as a nervous system with sensors, video cameras, social media, and other inputs, providing the city operator and community with constant data and feedback so they can make better decisions. From smart lighting that helps keep city lights on, to digital crime fighting using facial recognition, to intelligent transportation and beyond, cities are clearly poised for modernization upgrades to become smart. These technology-driven solutions are redefining the business of running a city and have equal influence on how cities generate revenue as well as how they own and manage assets. In fact, the potential benefits of digital transformation in cities are huge. Digital cities can generate $2.3 trillion globally through 2024. The deployment of these innovative new technologies can even provide a single pane of glass view of all of the community's data and cross-domain intelligence. This includes the capability to collect, aggregate, and refine data, then distribute it for faster response, improved decision-making, and more informed long-term planning efforts.
That video was pretty self-explanatory, but what is important is, yes, by digitizing the data, by making all the information about the city services available to the citizens, there's a lot of time savings, there's a lot of savings on transportation that is required, a lot of carbon emission gets reduced, and overall it makes the economy much more smoother. But to do this, there are new kinds of job opportunities that are going to come into the market, because a lot of infrastructure has to be deployed, has to be developed and deployed in the cities. So new kinds of cameras are coming in, new kinds of sensors are going to come in. These sensors would have to be deployed. Their deployment have to be managed at various command centers. You have to be able to make firmware updates on these devices. You have to make sure that they are commissioned properly. So these are the new kind of non-IT jobs that are going to hit the market, and that requires a significant workforce to go and work for them. And IoT is disruptive, right? That's the third characteristic. It can work in any domain. It does not matter. I gave you an example of a government initiative, which is in terms of smart cities. I'm going to give you a couple of additional examples, which are coming from areas of consumer electronics and the manufacturing sector.
I start my day like a sun rays. I tap the phone, coffee's on. I mow the lawn, and cussing Sean. So connected, so effective. I let it drop, clean it up, heat it smart. I do my part, get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, IoT. I check my stocks. What a shot. Buy some bonds. My oven's on. Coming home. Future song. All for me. IoT, IoT, IoT. Produce like a boss, easy use. Connect machines like a boss, perfect team like a boss, flexible mind like a boss, to make it mine. No downtime like a boss, that's worth the rhyme. Excuse me, did you say no downtime? That's not true, we have scheduled downtime. Like a boss, control the tech like a boss, phone check like a boss, go find me like a boss, IoT, IoT. So efficient, that's a mission. Never stress like a boss. AR test like a boss. Data cloud like a boss. Makes me proud. Together we like a boss. Save energy like a boss. IoT, 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 IoT. Manufactured like a Bosch. With many innovations for the factory of the future. From Bosch. IoT. Live like a Bosch with many connectivity solutions for a smarter future.
Yes, that's a fun ad. But yeah, IoT is getting into consumer electronics and the manufacturing sector as well. Now, in the process, IoT does not, all these connected solutions, they are very, very personal as well, right? They does not, when you build an IoT solution, when you build an IoTized workflow, we do not expect the audience or the end users to change the way, change their behavior of, how they do their things. It is rather the machines that adapt and try to keep things the way they are, right? I'll give you an example from a recent innovation in the smart cart sector that Amazon introduced.
of the Amazon Fresh Store in Irvine. This store just opened today. It's Amazon's newest and biggest supermarket. I want to show you how the store works. When you come into the store, you got an option. Do you pick a regular shopping cart or the dash cart? These are smart shopping carts where they're all computerized. They've got screens. You can shop with the regular shopping cart, but this is what you want to use. And let me show you how this cart works. And then we're going to take a look around the store. So the cart's really smart. But when you come in the store, you'll put your Amazon QR code here for Fresh from the app, and that's how it knows it's you. And then here you put a couple bags in it. It's got cameras, it's got lights, and so it detects everything that you put in. So now how do you buy items in the store that have a barcode? Well, this is pretty easy. All you do, you take the item and then you just put it in the shopping cart. The shopping cart recognizes it, and then you can see back here on the screen, we've got mother-in-law's kimchi, $7.99 each. You know what? That's actually a little more than I want to spend on kimchi. When I take it out, it recognizes that I took it out again, and then you can see back here on the shopping cart, quantity 1 removed. So to put produce into the smart cart, first you have to know the PLU. What's the PLU? It's a code on the oranges. It's right here. It says these are 3107. So now we're going to go to the smart cart, and right here it says add PLU item. We're going to click that, and then we're going to put in 3107, and we're going to hit enter. And it says, hey, look, that's oranges, and it has a scale in the cart. So we're going to take these oranges right here in this bag. We want to take a look at, and we're going to put them right here in the cart. And as we put it in the bags that are in the cart, now we'll look back here, and we'll see it measures it. That's 3 pounds 25 right there, $1.90. Confirm weight. Ta-da! We just got $1.90 of oranges. So you want to find things around the store, you can just ask Alexa, Alexa, where's Marsala wine? Find Marsala wine at aisle 11 and aisle 16. We'll find it in aisle 11 and aisle 16. And look, because I know what it looks like, I can tell it's right there. Super easy to find Marsala cooking wine. And with a smart cart, you just push it out over these green arrows, and as you do that, your credit card automatically gets charged. You get an email. Right over to the black carpet right over there. Awesome. So it's going to automatically sign you out, and it's going to send your email or your receipt or email. Okay. All right, you're all set. All right, you're all set. And then you just pick up your bags and you go. It's almost like stealing, but better.
So that is important because it shows how the process of buying has not changed. But what is important is that they have commercialized this whole solution. It is not a prototype that they are that people are experimenting with. IoT has become very, very mainstream, and you see the set of sensors that the entire ecosystem is equipped with. There are QR scanners that are reading the barcode from the phone, and it's kind of signing your profile in. There are cameras which are reading the barcodes. There are user notifications that are generated through the lights. The screen gets updated. There's a scale that is there in the cart, and which is weighing the items as you put them in, and it kind of resets after you've put in every new item, right? And the screen gets updated. And when you're checking out, it detects that you are moving in the checkout area. It initiates a financial transaction, charges your credit card, and the length of the exit path is such that by the time you cover it, it's your billing is already completed, right? So in this IoT system, what we are seeing is that there are these devices which are sensing this information. There are devices that are linking this information to other information systems, and there are devices which are trying to understand our requirements. They're trying to predict what our requirements can be, right? And these are all coming together to form a unified, seamless workflow. In this case, our reviewer, he queried Amazon Alexa to ask about where a particular product is. And this is not unique, because IoT by definition is something that becomes very context aware, right? It brings back to that old question of how many engineers does it take to switch on a light bulb. And when it is a smart light bulb, well, things are a little complicated. If you look at Alexa or the smart lights that are available for usage at your home today, it's a simple thing of switching on a light bulb, but the way it is implemented is actually pretty interesting, because the first thing you have to do is you have to commission the system. You commission it over a out of band network, over a Bluetooth or something from your mobile app, and register this particular device with a device cloud in the backend, the manufacturer's device cloud in the backend, and you connect the device cloud to your conversational, to Amazon's conversational platform, so they know that this device is registered with you. Thereafter, when you go in and say, like, something like Alexa, switch on the lights, the word Alexa is actually recognized by a hardware engine on the smart speaker itself. Once it recognizes that wake word, the rest of the vocabulary, which in this case is a voice packet containing, switch on the lights, that gets captured, and that information will get sent over to Amazon's conversational platform. Now, Amazon's conversational platform, when it receives this packet, it doesn't know where this packet is coming from. So it's going to look up the user profile and say, hey, who has issued this request? It looks up that user profile, and then it says, okay, what are the devices that are registered with this particular user? It finds those devices and said, who are the manufacturers who have made these devices? Because the Amazon platform does not operate this particular device. It is operated by the manufacturers. So it looks up the device cloud and looks up the access credentials for that. Then it goes and calls the skill API, which is the on API in this case. So it's going to call the on API on the device cloud with this particular user ID. The device manufacturer will now look up what is the device ID associated with this particular user, and it is going to issue a command for that particular bulb. Now, because this bulb is behind a firewall, it is behind a home router, its IP is dynamic. So it has to, the manufacturer's cloud has to figure out what is the current IP that is associated with this device. So it looks that up and sends a command which is received by some code that is sitting on the bulb itself. It will switch on, it does the activity and gives an OK response. The OK response gets back to the device cloud, which in turn gives a response back to Amazon's conversational platform, which in turn encodes this as a voice packet, which says maybe OK, which goes back to the smart speaker, which plays back that OK. All of this thing is happening is in less than, in probably a few milliseconds. The experience of switching on the bulb is pretty much instantaneous, but yet this process has now taken us through multiple transactions, multiple digital interactions involving systems which are not governed by a single entity. It has taken a third party, it could be a third party's smart speaker, it is Amazon's platform, this is a device, a vendor's platform, this could be the same vendor's light, or it could be outsourced from some other vendor, and the phone, of course, is from a different vendor. So there are multiple such systems which are coming together and enabling this particular transaction to go through seamlessly. That's the beauty of IoT. And clearly, it now takes many engineers to switch on a light bulb. So to that extent, IoT is starting to become very, very intelligent as well. Right? It is a case where it can help with things like automation, where it kind of helps us to overcome our inertia of rest, where as we are leaving the house, we say switch on all the lights or switch off all the lights. So that's kind of an automation behavior. Or it can give us this kind of real-time behavior that we saw with the Volvo ad, where the system acted before our intervention and saved the life of a person. Or it could be used for generating recommendations with respect to the next best available action. When we have a multi-parameter situation where there are multiple things that needs to be considered, the system can compute it much faster and give us a ranking of each option, right? So that we can it helps with our decision-making process. It's a system that can learn. For example, when we all of us have used Google Maps for traffic navigation, and over time you will see that these predictions of it's going to get traffic in these areas, avoid these roads, right? So these are kind of learned behavior from how the community moves around, where those traffic snarl ups have typically happened over time. And it can be used for prediction as well. We see that in cricket, when we have a ball tracking system, and when the umpire asks for a review, it tries to forecast how the ball would move after, if it had not hit the batsman, right? So these are kind of predictive systems that are coming in. Talking about cricket, IoT has, is a lot of infrastructure that needs to be deployed. So I'll give you an example from cricket itself.
Technology is changing the way we see and play the game. Stance Beam Striker is a lightweight device that's designed to give you real-time bat speed, power factor, swing angles, shot efficiency, and many other important aspects to help you improve your batting. Turn your bat into a smart bat. Capture every shot on a smartphone with Stance Beam. Just play your game and then review at your own convenience. Because with Stance Beam Striker, you can now monitor sessions through videos and 3D simulation.
So when you break up a complete IoT solution, what you will find is that there are these sensory systems. There are this, in this case, this is a accelerometer, a multi-axis accelerometer and gyro that gets packaged along with a power source, charging mechanisms, and plastics that's going to keep everything in place. So that's the overall sensory system at the end of which is capturing the data. And then you have a communication system, which is getting that data from that sensor either through a phone or through some external Wi-Fi infrastructure. There are multiple radios that are available today for IP-based communication. 5G is there, 4G is there. You also have Wi-Fi, even Bluetooth can be used for IP communication. You have a lot of low power wide area networks like LoRa, like Sigfox, narrowband IoT. So there are multiple communication technologies that can be used. And then there are these user systems, which is processing that information and giving the user insights about how whatever the system is. It's giving you very precise action items. It's visualizing the data in a form that can be understood by the end user. And of course, for historical purposes, a lot of the data is actually getting stored in the cloud backend. Now, this is one form of architecture. Depending on the use case, there are multiple architectures that are available in terms of where that data should be stored, how much data should be stored, how the user interface should behave and look like. One important thing that is not shown over here is, or which is rather hidden from our view, is the enterprise management system, the system through which all the different sensors are connected to the system, how they are commissioned, how they are associated with the users. All of that information, somebody needs to be able to go in and manage that. Those are the enterprise systems with their own portals that are kind of hidden from the user perspective. So that's the infrastructure of one system, and every system pretty much there are smart balls that are out there. There are, you see the LED wickets that are available. So there's a lot of these IoT systems coming in, not only sports, it's coming into healthcare, it is coming into textiles, it is coming into manufacturing of shoes, it is getting into structural engineering, it is getting into cement curing. So any area that you pick up, IoT has pervaded that area. It's becoming like almost like a technology gateway, because to build that workflow, you need to absorb a lot of emerging technologies, right? For example, you need to understand a lot of machine learning and AI, where the accurate models are being made for each particular application. Uh, the user interface is in terms of a mobile app, so a lot of a lot of user very cool mobile app development is going on, especially for the consumer applications. A lot of algorithms have to be developed to reduce the complexity and power requirement, the time complexity, the space complexity, and the power requirements of searching systems, of lookup systems that are being used by IoT applications. There are a lot of cloud ops that are getting used. For example, today, if you wanted to if a smart speaker wanted to use a voice recognition system, they would not everybody would go and build their own voice engine. They would use a voice to text conversion service, where the service is running as an infrastructure on a third party cloud. Web development, all the management portals are essentially full stack solutions that are being deployed in the backend on cloud infrastructure or on private data servers. And that's where the control rooms that are being created for smart cities, those are getting hosted. Then there's security. IoT transactions, they need to be recorded. Blockchain gives a very good mechanism to create an immutable data record, right? So any area, any of these emerging areas that you can think about, all of these are very tightly coupled with IoT based systems, which makes IoT as something that is future ready. It is something that is a career path for a lot of you, because it requires various kinds of experiences and various kinds of inclinations. A lot of IoT solutions, especially in the smart cities, require large deployments, right? And this is where field engineers are required. Field testing is required, because unlike software testing, which you can sit at home and not sit at home, but you can sit in an office and you can write a script for testing it. If you had to test how a GPS system behaves, very likely that you'd actually have to go out in the field and do it. Right? A lot of people might be oriented towards the academic portions, thinking about an academic career in IoT, in which case you need to start doing projects which are mapping with the universities and the programs that they are going after. So there's a lot of academic research, algorithmic research that can go on in that aspect. A lot of people might be interested in kind of tinkering around, integrating various clouds, and creating very complex workflows, that they are very well suited for creating these prototypes, right? Where there are other folks who are going to be taking a solution and taking it deeper and deeper, creating a very niche solutions, who are perfectly positioned for IoT product development. Then there are solution architects who have implemented enough solutions to kind of give a piecemeal solution to kind of create a solution that is for a specific business case, right? And then you have to look at the business side of it. So there will be many of you who would go on to become product managers, understanding how what are the consumer requirements that have to be met by a particular product. But as a career path, you need to understand where your role is, or how do you see yourself moving in this area, or which area excites you the most, and then build your credentials accordingly, so that your role fitment is very clear for a potential employer. What does the future look for an IoT engineer? It's great. The IT industry has been around in India for almost the past 30 years, and it's at about 600 billion today. It's expected to grow to about $1,100 billion by 2025. The overall IT industry. That's a good growth rate, but that's a growth rate of about 5 to 6%. The IoT industry, on the other hand, is expected to grow from about $212 billion last year, or last to last year, to about $1.6 trillion. That's almost a 26% growth rate, with managed services growing at 30% annually. What that means is there are new opportunities. There are new opportunities that are going to be presented, and there are new companies that are going to be there to take advantage of this growth rate, and the opportunity to grow along with these companies is very, very high. I told you about the various options that you have in your career path, right from field engineers to IoT, being an IoT developer, working in cross end-to-end workflows. And as you grow up, you can become solution architects and product owners, and even entrepreneurs, right? But out of college, there are very good opportunities in these three segments. The advantages, well, it's new, so there's always a first mover advantage. The salary levels for IoT product companies is relatively better than in IT companies. So there's almost a 40 to 50% higher salary that you kind of start with. It's a startup ecosystem for dynamic people. It means that it's inorganic growth, and there is an opportunity to disrupt. And wherever there's an opportunity to disrupt, there will be higher visibility. A lot of you may not be coming from IoT, from core IoT areas, but then you might be coming in from other disciplines, so like electrical, like mechanical, and there's an ability to still leverage that knowledge and build on top of that, build IoT systems, taking advantage of the experiences you have picked up in your engineering program. Right? Finally, going for IoT does not curtail any of your current opportunities. You still have your opportunity to work as a web developer. You still have an opportunity to work as a mobile developer. So it kind of preserves all your mainstream opportunities that are available, but it gives you that extra edge. Because more than the services company, if I kind of segment out the various disciplines who are recruiting in IoT today, you'll see some very, very large companies there, all multi-billion-dollar companies, hundreds of billions dollar worth of companies, right? In the semiconductor segment, pretty much everybody is building an IoT chipset, whether it is on the communication, Wi-Fi chipsets, Bluetooth chipsets, or it is sensory chipsets, or it is computational chipsets. So a lot of companies which are there in the semiconductor space. In the connectivity space, Vodafone has been setting up its own LoRa network. Jio and Airtel, they have been working on their on the narrowband IoT networks. Tata Communication has been working on its LoRa network. So there are opportunities with the communication service providers. Every cloud provider, large and small, are offering native cloud services, right? Native services for IoT, be it in terms of integration with simple notification services or storage services or IoT gateways, right? So all of these clouds are present today in the public space as well as in the private infrastructure space. There are several companies which are in the solution space. They have industrial solutions, they have enterprise level solutions, they have communication specific solutions, or they have electrical solutions, right? Which are end-to-end use cases for their respective markets. And then there are, of course, companies like the Infosys, like the Mindtrees, which have a solution engineering and services business that is there, right? So in all, the opportunity is not limited to only the core IT companies. There are a lot of other companies that you should look at as you graduate, and that kind of opens up the opportunities to make a new career out of it, right? So that's pretty much what I have so far, right? With that, I will open up for questions. Yes, let me go through some of the questions which has already come in, right? And then I can please send in your new questions. So Pranay asks, how will the shopping system increase different types of jobs for students? So Smart retail is a segment by itself. It is not only with respect to the shopping cart, which facilitates shopping. There are also a lot of smart mirrors that are coming into play, which allow you to kind of take up kind of have a wardrobe, post that wardrobe, ask for feedback from your social network, and make a decision based on that. Retail uses a lot of technologies for counting footfalls, how many people are coming into the retail store, how many are going out. It uses a lot of technologies for understanding hotspots and how shoppers move about within a mall or within a shop, which are the areas that get most interest, which are the areas that get less interest, and accordingly they can place their products accordingly. There are aspects of smart shelves which kind of tell you when a shelf is running out of its inventory. There are smart labeling solutions, which instead of having somebody go around the whole shop and have write down the price of every product, you have electronic shelf labeling systems, which are automatically updated from a backend server. So sitting at a corporate office, I can set up new price lines, and it will be reflected across all my stores across all the entire country, pretty much instantaneously. So there are a lot of smart solutions or IoT based solutions that are available for smart retail. And that is where there are companies which are focusing on each and every one of those solutions, and that's where the opportunities for students also lie. Will automation cause a job crisis, is what Guram asks. Automation will create new kinds of jobs. It is like today, when you go to a railway station and you want to book a ticket, the railway clerk is still there. They have a computer beside them which is actually issuing the ticket. So it makes the system more responsive, but that hasn't taken away the job of the railway clerk. So similarly with automation, there will be the production quality that will improve, the downtimes will decrease, and yes, it will need a lesser workforce to maintain each of these systems, but new jobs are going to come out in terms of deploying, managing these systems, or in new kinds of areas where it is not possible to automate. But I believe that there will be more higher paying and a larger number of jobs that will be created because of IoT rather than taking away because of the automation. Harshit asks, is there a link between AI and IoT? Absolutely, absolutely. Not There is a very strong link between AI and IoT. For example, recently I came across this particular app by a company called Hawkeye. Everybody's heard of Hawkeye, and they have a smart voting system where when there is an indecision and there's a possible run out or something like that, you can ask the fans a question: is this out or not? And the fans, when they are coming into the stadium, they are given a kind of a bat which has a green side and a red side. One is a not no and a yes kind of a side. There's a imaging system. It takes a picture of the entire crowd, and it can at runtime figure out, count the number of reds versus greens. So it's an automated voting system. That's an example of where IoT and AI kind of comes in together. You are using a lot of video processing, image processing to recognize these artifacts and kind of to look at the color for each of them and come up with that count, right? So do we need to learn AI to run any IoT applications? Most IoT applications will have some kind of models that is there in place. Now, is that a deep, unexplainable model as in AI, or is it something that is more of a statistical model, or is it something that is more of a threshold-based model? It varies. It could be something as, something like a temperature a thermometer, a clinical thermometer, which gives you a temperature value, and you can put in some automation there saying, is it fever or not? So it can be as simple as that to something that is, that is multi-parameter and takes in a lot more complexity. Mohammed Fakhruddin asks, how does 5G influence IoT industry? Well, there are two kinds of influences that are coming in. One is applications which require very high data rates, especially applications which are related to augmented reality. That's where high speed makes a lot of difference. And then there are other kinds of applications which require very low speeds. That is where the industry standard in 5G accommodates a new technology called narrowband IoT, which is for machine-to-machine communication. Right. Uh, Shreya asks, what kind of knowledge and skills should we have to get into IoT? As I mentioned, IoT is a technology gateway. You can develop a skill set in any particular area. You could be a very good mobile app developer and get into IoT. You could be a very good web developer and get into IoT. You could be an extremely good cloud, DevOps person and get into IoT. You could be a machine learning expert and get into IoT. You could be a blockchain expert and get into IoT. You could be an embedded engineer and get into IoT. So you can bring in, but the important thing is you have to be good at one thing. The moment you are good at one thing, you can start contributing to that entire workflow and contribute on adjacent areas as well. Shubhasankar asks, is AI more better than IoT? I guess it is very subjective, because AI, when you boil it down, it's boiled. When you boil it down to what exactly is AI or what exactly is machine learning, then it comes down to a few statistical processes, a few conditional probabilities, things like neural networks or genetic algorithms, right? Where you can use those in other areas as well. You can use neural networks irrespective of IoT. You can use it for natural language processing. You can use it for optical character recognition or pattern recognition, and that system can itself be used by IoT. So it is kind of complementary. AI is strongly used in IoT systems, and it can also be used in other systems, vice versa. IoT can use AI, and IoT can be run without AI as well. Govindaraju Rajalu asks, are there any books for beginners in this field? This is still an emerging field. There are quite a few books out on Amazon, but the best way is to go and look at solutions that are available on YouTube. If you are looking at architectures, feel free to get in touch with me if you need to. Right? But I don't have any specific foundational book that is there for that I am aware of. Most of them have dealt with either a specific type of IoT or a specific set of applications. Of course, there are a lot of books on sensor networks, which is more on the mesh networking part of it, right? But nothing on different IoT architectures. Skill sets companies. So Kolli Jyotsna asks about resources for beginners to know about the skill sets, companies, domains. I guess I already kind of told you, I kind of segmented it out in terms of the semiconductor companies, the communication companies, the solution companies, the cloud companies. So I gave you a list of skill sets and companies that are going to be available, that are already available. How's the future for IoT and AI domain? Absolutely great. Everybody who needs to build an IoT solution will have some kind of a model. And if you're good at building those models, that is very, very valuable. But you need to do some projects. You need to keep doing projects so that you enhance on that skill set. Chandrasekhar asked, IoT in healthcare industry, measurements of vital signs of humans. There are several aspects to that question, because in the healthcare industry, again, there are invasive methods, there are non-invasive methods. So today, even an invasive process like a pacemaker has a Bluetooth connection, so that it can be tuned externally. Right. What the benefit is that you can change the configuration externally, and you do not have to operate and take out the pacemaker again. So even invasive applications are being used. A lot of the MRI machines, CT scanning machines, they have IoT systems, so that any fault is in the magnetic field or its readings can be pushed out to the service centers, so that they can come and fix it before it kind of fails. So there are a lot of predictive maintenance solutions around there. In the consumer segment or in the clinical segment today, there are connected thermometers, connected weight scales, connected blood pressure cuffs. There are connected SpO2 sensors, connected spirometers. So there are a whole lot of connected products that are available. Then there are home healthcare solutions where these connected platforms can be, they can be brought together, and you can get a holistic view of the patient's health. Right. So IoT in the healthcare segment being used very extensively. This is on the This is on the consumer appliance side of it. It is also IoT is also used in the storage and transmission of medication, in terms of identification of drug fraud. It is used to ensure that vaccines, they do not break the cold chain during their transit. So those kind of applications are also happening. Google Modi asks if we can talk about narrowband IoT in India. There are already significant or advanced level trials that are going on. Airtel is deploying. Airtel and Reliance Jio, they are the pioneers of NB-IoT deployment in India, to the point where they are making their NB-IoT chipsets, NB-IoT SIM cards available for test markets and prototyping markets, but it's not been sold for end user consumer market right now. Right. Chandana asks, what is the role of cloud in IoT? Well, IoT generates a lot of data, right? So there is where that data is going to go and sit. That is an architectural choice. Some of it, like factories, they don't want all the data to go back to the cloud. They kind of prefer storing it in the within the premise itself. A lot of systems are generated so that the entire data goes back to the cloud and they have to store it. So the cloud is essentially, it serves two roles. One is it provides the infrastructure where the IoT applications can be stored. That's that's the basic level of service that the cloud provides. The second level of service is it provides native solutions or native components in that cloud itself. For example, Amazon's AWS will have its IoT hub infrastructure as a service. It will have its stream processing as part of its analytics service that it can offer. Microsoft offers a digital twin service. So each cloud has its own set of native offerings that are available that can be used in IoT systems. They will provide their own notification services. They'll provide their own user management and identity management services, right? So these can be used as services, or somebody can use just the cloud infrastructure and deploy and build their own services on top of it. And both options are available. It's a cost versus timeline kind of a question. Kohli asks, is getting an internship in this field very difficult? Well, yes and no. The challenge is for an internship, a lot of the IoT applications are being developed by companies which are still in a startup mode. So what they are expecting is, they get to know, where do I fit a particular role, right? When I talked about IoT being, see if I can. Yeah, when I talked about IoT having several aspects, when somebody works in an organization, somebody who's coming in as a lateral, the employer, the hiring manager has a sense of where this candidate can be placed. But when somebody is coming out from college, it is not very clear that in 2-3 months what is the problem statement that they can solve. Or so that is why it is a little difficult to get internships. But with more and more companies coming into the IoT ecosystem, it is going to become easier and easier to get these internships. You have to understand that a lot of these IoT companies are still in incubation. A lot of them are still running very small operations. So I think it will take another 12, 15, 18 months before these organizations kind of grow to a scale where they will start taking in internships. If you have additional questions, get in touch with me. Right. Chandana also asks, can you explain in your own experiences and challenges in the field of IoT? Well, that's a very, that question will take ages to solve. There are two main challenges that I see. One is on the requirement side, where we tend to think of IoT as a silver bullet that is going to solve all the problems. But a lot of times, an IoT solution is not just about connecting. Let me see. An IoT solution is not about just connecting a sensor with a mobile app. That is the strongest misconception that stays around, right? To operate an IoT solution, there are a lot of other infrastructural pieces that needs to be considered. And in a lot of cases, when you look at the solution in its entirety, a customer may not be really prepared to make the financial commitment or wait for the return on investment, right? So that's where good architects are needed to balance the offerings, the value of the solution versus the cost of building that solution. uh, the other challenge is from the workforce perspective, where we are the engineering workforce that is available today. I think they are not yet ready to think of the entire end-to-end workflow, and there are very few engineers who are able to navigate that wide expanse of technologies that is required to create the working prototypes, right? Uh, to tell you about my company, Capsule Labs is focused on engineering education as an engineering finishing school, primarily around the third year, final year, gap year, and the first jobbers. What I find is when students or when fresh candidates, fresh graduates, they come in for their interviews, they find it very hard to explain their projects, or they find it very hard to articulate what is their contribution going to be in a particular organization. And part of that is because they have done group projects, and they've taken on a very curriculum centricity in their engineering program. So I try to take them away from that curriculum centricity and look at projects, take a very project centric view to the entire project, try to understand what is the goal of that particular project, where do they want to go with that particular project, and which skill sets they want to improve. So it's a very consultation driven project management that we take the students through, and so that at the end of it, we are able to track the inherent behavior of the candidates and help them articulate their value to their potential employers much better, right? If I have two ways in front of IoT and AI, which is a better path to choose and why? Okay, good question, Kohli. Now, I answered that question in a little bit by saying that you can preserve your current mainstream opportunities. IoT does not take away from that. So if you are somebody who wants to focus on IoT, on AI-based solutions, build an IoT solution which uses AI. Use a device as your sensor, as something that is collecting data. Use the device to send in your data, and then focus more on how you are using AI to manipulate that data, right? For example, if you wanted to make a smart camera, that is where you can use a lot of AI, using a standard camera and processing that entire information on a desktop grade or even a server grade machine. Do it, see which part you are enjoying more. If you are enjoying the IoT pieces of it, which is, when I say that, I mean that you build up that model, and when you try to fit that particular AI algorithm in the limited constraints of an embedded device, you will find a different set of challenges, right? So both of them have their benefits. If you are a good embedded implementer, if you can implement AI solutions on embedded systems, people will pay top dollars for you. If you can build good AI solutions, people will pay top dollars for you. AI, if you go down that path and start looking at how quantum computing can help you in that AI field, how it can help you reduce your search space significantly and give you very quick responses, very low latency responses to complex questions. If you think that's where your talent lies, I would say go for AI. If you think you are more comfortable in working within an embedded system, go for IoT. You are asking about the scope of the field. I would say that both options are open for you. IoT is something that is present right now. AI is something that is developing. AI is something developing. Your success will depend on not which problems you pick up and try to solve, but which problems you actually solve. Because you can start multiple things, but it is what you deliver that will make up your credentials as an engineer. AI sounds very fascinating, but it becomes it quickly becomes very unexplainable. The mathematics of AI, the probabilities of AI, especially with deep learning, and it's why you are getting a particular result, that is not always obvious. So there are areas, something called explainable AI that is coming into the market, where you are able to follow through that entire space. So I guess at the end of the day, it boils down to you where you are more comfortable. If you are more comfortable in handling the maths part of it, I would say go for AI. If you are more comfortable in the engineering aspects of embedded systems, the race conditions, the threading conditions, the timers and all of that, I would say go for IoT. Scope wise, both of them are open. Both of them are open, and both of them are niche fields.
Yes, sir. If you don't have any questions, I'll end with a thank you note.
Somebody said, how can we progress in the field for the first year? It does not depend on which you are in. It boils down to where your interests are. If you can spend 15, no, depending, just take an example. Take out whatever time you want to spend on this. Take out 8 hours a week or 10 hours a week, and we can easily come up with a plan of what you can achieve in even a semester. Right? If you take out 8 hours of week and you break down your project into something that can be achievable in that time, right? You can start doing projects. And the process is, when you get stuck, you will learn. There are enormous number of resources that are available on the internet. I don't teach anybody coding. I expect them to go back and find out the solutions to their problems, and that is the best way of learning. As you graduate, as you come into the workforce, what is important is your ability to learn rather than what you know. Those are all very excellent questions that I've had so far. Thank you all.
So, yeah, if you don't have any questions, then I'll end with a thank you note, sir.
Yeah, and anybody wants to reach out to me, please feel free. So I will. You have my contact information, so please reach out if you have further questions.
Yes, sir. Actually, we have prepared a thank you note, sir, but after watching this, I just don't want to read it out. I just want to speak out.
Sure. Please go ahead.
Um, Actually, when we started the club, we were not sure of who was interested in IoT and all. But after seeing the questions, I'm glad that there are a lot of people who are really interested in IoT in our university. And we are happy to see the number. I mean, the number was not satisfying, but the number of questions were quite satisfying, actually. And this shows their enthusiasm towards the topic and the subject. Yes.
Absolutely.
And thank you for sharing your precious knowledge, sir, with us. And I think it's going to help them in every which way. And yeah, thank you, sir.
Sir, I'll just add, sir, generally we in our classes we usually get bored because it is online. But on your session, sir, we were just stuck to the screen. I couldn't move, and every bit of knowledge was worth it, sir. And we have a lot of things that were cleared, and we see IoT as a very big field right now. And we feel there's a lot of scope for our careers in this field. Thank you so much, sir. It means really a lot that you came and you did this for us. Thank you so much, sir.
And
Thank you all. Thank you all
Thank
for
you.
being such a patient audience.
thank you, sir.
I'm Farooq.
And
Hello.
I'd like to thank all my club mates who have took part in the organization of the event. Farooq and Chandana and Pranay. We have a few more. Thank you.
Have a good evening.
Thank you, sir.
Thank you, sir. Thank you. Thank you so much, sir.
Thanks a lot.
Thank you. Thank you, everyone, for attending. Thank you so much. Thank you. Thanks a lot.
Yeah. Yeah. Thank you, guys.
Thank you. It means a lot that you guys could
More
attend.
events.
More events are coming up. Just stay tuned, okay? Thank you. I just joined Discord, okay?
Yeah. Okay. Yeah. You guys can leave. Thank you, guys.